We were talking about, on 166. Now, 167, it talked about the atmosphere. Hopefully you read this. If you haven't, you need to read it. 6.3. The atmosphere of Mercury, which doesn't have much of an atmosphere. Mercury's so small, it's kind of like the moon. It can't keep an atmosphere. But Venus has an amazingly thick atmosphere. And this is the atmosphere of Venus seen with ultraviolet light, which can penetrate the clouds a bit.
Looks kind of like Earth.
It does with ultraviolet light. But visibly, it would just be these white sulfur clouds all the way through. But we do see storms and such with the atmosphere moving around. Venus's atmosphere is mostly carbon dioxide, which we'll talk about why that is a little later, but all the oxygen and water are gone from the atmosphere, and you're left with mostly carbon dioxide atmosphere, very thick.
Is there water like on the planet?
There's not.
So
There used to be, but it's all gone. And it's due to a runaway greenhouse effect, is what it's due to, which they talk about at the end of the chapter, and we'll get to it. But it got so hot there that all the oceans evaporated and all the water got broken apart way up in the atmosphere, and you're not left with any water anymore. The hydrogen escaped into space, and there's no water there. We'll talk about that a little bit later. 6.4 and 5 is what we're going to talk about today, the surfaces of Mercury and Venus. Now, Mercury, we know about the surface because we flew a spaceship, America did, the Mariner missions. There were 2 Mariner missions that went around Mercury and took a bunch of pictures, and that was back in the 1970s. And then in 2008, a spacecraft called Messenger flew by Mercury and took a bunch of pictures. So we got a lot of pictures of Mercury. And Mercury basically looks like our moon does. It's got a bunch of craters. It doesn't have any atmosphere, so the craters never erode. They just kind of stay there. So if it got hit by a crater 2 billion years ago, that crater's still there today. If you count the number of craters, we find that Mercury doesn't have as many as the moon, though. Because Mercury was hot for longer than the moon was. And so at one point, very early in Mercury's existence, there was a bunch of lava and stuff that would come out of volcanoes on Mercury and cover up some of these craters. But now, Mercury's cold and doesn't have any more seismic activity, and so there's no more lavas and such. There's a picture of Mercury. Looks kind of like our moon. You can still see some large impact craters. You can see where there's an impact there, there's lines streaming from it where stuff was thrown. There's a huge impact crater up there. And this is looking closer up at Mercury. You see a bunch of impact basins and craters inside of craters, just like we see on the moon. There's one surface feature that Mercury has called scarps. Mercury has scarps, which are huge cliffs that resulted from the crust cooling and shrinking 4 billion years ago. So here's basically what happens. When a planet is hot, it expands. When you heat rock, it expands. Because the molecules move faster and you have expansion. And then the outside of the planet cooled and hardened, so you have a crust. And then the entire planet itself started to cool. And imagine a hard, crusted object cooling and contracting and getting smaller. So what happens is, if I take this large ball that has a hard crust on the outside and I contract it, it contracts like that and gets smaller, and you end up with one part of the crust kind of overlapping the other. There must have been some huge earthquake in Mercury's past where the whole crust shrunk. And now look how my fingers sit over my other hand. That's a huge cliff right there, hundreds of miles tall, that we see all along the surface of Mercury. It's called a scarp. So that's what Mercury did a long time ago. And you have these huge cliff rows called scarps. And so here are pictures of those. See these lines right here? You see that line right there? Going all the way up there? That's a scarp. And you look at it and you say, well, that's not that big. It is. It's real big. It's just seen from outer space, so it makes it look smaller. And there's not just one scarp. There's many. When it shrunk like this, it didn't just do it in one spot. It did it in many spots. So there's all these lines going across on Mercury that are called scarps, and you don't see them anywhere else. There's some more scarps right there. You see that line? And here's... I don't know if that's one also. That might be part of it. You talking about Mercury? There's a huge bullseye crater called the Caloris Basin where a huge asteroid must have struck. Measures 1,400 kilometers across, ringed by concentric mountain ranges that reach more than 3 kilometers high in places. It's about 10,000 feet. Huge circular basin is similar in size to the moon's mare and expands more than half of Mercury's radius. There it is right there. This is false color. This isn't the real color. The computer has colored it so you can see it better. Let's see a little video footage of it.
The closest planet to the Sun in transit across the Sun, baked little Mercury on the inside track. To understand Mercury, we return to the early solar system. A disk of gas and dust rotates around the newly fired up Sun. Hot and dense at the center, farther out the disk is diffuse and cool. Close to the Sun, tiny particles condense, heavy materials with a high melting point. Beyond, grains are lighter and icy. Particles begin to clump. And the great disk starts marshalling into rings. Everywhere, collision and aggregation. Grains grow as big as basketballs, houses, mountains. And as they grow, so does their gravitational pull, offsetting the tug of the Sun. Rings in the disk are increasingly defined, and within them, mini planets are forming, so-called planetesimals, constantly growing as they sweep up debris. But But it's still a mayhem of impact and assimilation. The bigger the body, the stronger its gravitational pull, and the more it grows. Thus do the planets shake out. In the farthest reaches, great spheres of gas riding vast and lonely orbits, but closest to the Sun, solid little planets. Debris remaining between the orbits is blown away by the solar wind. The veil is lifted on this empire of the Sun. And the Sun still rules some 5 billion years later, with dense little Mercury the closest subject. Mercury, Venus, Earth and Mars are the rocky inner planets, the terrestrials, where the heaviest elements condensed. Jupiter and its fellow giants are balls of gas. They condensed in these cold outer regions from lighter elements. With the Sun just 58 million kilometers away, Mercury is scorched and irradiated as no other planet. It's named after the messenger of the gods, and why not? For the ancients saw the Sun as a god. Mercury is the smallest inner planet. Earth is 18 times as massive. Compare their diameters. Mercury is less than 4,900 kilometers. Earth is over 12,700. And they've different attitudes. Earth tilts. Mercury doesn't. Twilight on Earth, with Mercury on the right and Venus above. As they move through their orbits, they're never high in our sky. Mercury is the most difficult to see, barely clearing the horizon at dusk and dawn. A change of perspective shows why. From Earth, we see only part of their tight solar orbits. Venus, the outermost, orbits in 225 days. Mercury in 88. Mercury crossing the Sun. Such transits occur 13 or 14 times a century. We see them because Mercury, just like Venus, lies between us and the Sun. (1973) Blast off for Mercury. The mission is Mariner 10. Using the pull of Venus as a push towards Mercury, the craft was the first to use gravity assist, now a common technique. 2 months later, Mariner skimmed Mercury at just over 700 kilometers. There were 3 such flybys. They yielded a photographic feast. Here was a pristine record of the early solar system, the whacks and smacks that cratered this barren little world. Is the Zola crater, remnant of an impact so mighty that ejected material dug these mini craters. These craters could be in the highlands of our moon, another lifeless desert. From upper left come the streaks of a ray crater, the imprint of an impact on older terrain. Mercury has basins and less cratered regions like this. They indicate a younger surface, formed in a volcanic epoch when lava flowed. Great cracks betray a crust that has cooled and shrunk. Mercury has a mind-boggling calendar. Its day, sunrise to sunrise, is twice as long as its year. See how slowly Mercury spins as it circles the Sun. Watch the arrow. In a single orbit, the planet turns only 1.5 times. Earth, by contrast, would spin 365 times. The result is that Mercury's day lasts 176 Earth days. Mercury's year is just 88 Earth days. And it becomes stranger. From the surface of Mercury, during its long, long day, the Sun shrinks in the sky. Nothing to do with the Sun, all to do with the planet's varying distance from the Sun. Mercury has an elliptical orbit, and it produces an even weirder effect. Each time it passes close to the Sun, Mercury speeds up and slows again. The consequence on the planet is a double sunrise. And it happens only when Mercury is closest to the Sun. Been struck by a large planetesimal. Such an impact could have blown off the planet's outer mantle. That would explain, relative to its size, Mercury's huge iron core. It's 70% of volume, twice the proportion found in other terrestrial planets. There's no doubting the impact that happened here, with rings of mountains curving towards the left. This is one side of the huge Caloris Basin. The cause was another planetesimal. 4 billion years ago, it gouged a crater 1,300 kilometers wide. Splattered later with these smaller craters, the basin had probably filled with lava. The mountainous rim of Caloris, lava fields to either side. Volcanic activity lasted 1 billion years, but for the past 3 billion, it's been quiet. Lava plains surrounding the Caloris Basin. Caloris means heat, well named, for the basin can be Mercury's hottest spot, with a daytime peak of 450 degrees Celsius. At night, temperatures plunge to minus 180. And radar mapping suggests permanent ice on Mercury. Radio telescopes in the United States and here in Puerto Rico hint at the paradox. If it's true, ice could only survive on Mercury in deep craters at the poles. There, perpetually shadowed from the Sun, could be the icy deposits of comets. Most of our knowledge of Mercury is from Mariner 10 in the mid-70s. And that left more than half the planet, the blank areas, still to be photographed. But new missions are planned. This is Bepi Colombo, a probe to be launched by the European Space Agency. Like Mariner, it will slingshot via Venus. So much is to be gleaned from Mercury, with its wispy atmosphere of helium and a surprisingly strong magnetic field. Plan flybys with this messenger craft to better know the shape of this planet. Mercury's surface is the history of our solar system from the earliest times.
All right, well that was a lot of info. They said it had Mercury has a helium atmosphere that's it's so thin you don't consider it to be any atmosphere. I mean, there's a little helium that rises up from inside the planet and then escapes to the space. So it's not really an atmosphere like you think of. It's just rising and leaving. All right, let's see what Venus looks like. Page 170. The only way we can see Venus is through radio waves shot through the clouds because of these real white sulfur clouds. And we see that Venus has raised areas and lower areas just like Earth does, kind of like continents. And so they made a map of Venus. And this is what Venus's map kind of looks like compared to a map of Earth, say. And everywhere where you see white on this Venus map is considered a continent. Venus was probably at one time covered in water, just like the Earth is. And so there's 2 continents on Venus. They're called Ishtar Terra, right here, and Aphrodite Terra, right here. And Venus, probably being covered with water at one point, was like that. It was an ocean planet with 2 continents. Sort of like we have an ocean planet with 7 continents.
Will you go back? Okay.
Good?
Yeah.
Like I said, all the water from Venus is gone now. So you don't have continents like we have here. If you were walking on the surface of Venus, this area would be of higher elevation, and this area would be of lower elevation. But if there were a bunch of water on the planet, the blue area here would all be covered with water, just like it is on Earth. So it probably had plate tectonics at one time, where you had continents and movement and stuff, but it doesn't have it. Venus doesn't seem to have that anymore. This is a map of the planet. It's seen in a globe. It looks different in a globe than it does as a flat map. Here's the flat map: Ishtar Terra, Aphrodite Terra, and here's the globe. This is Ishtar Terra here, and Aphrodite Terra here. This shows a computer simulation if you were flying along Venus. I think that's what this is. And looking at it. No, that's not what this is. It just shows that same picture spinning. With the blue being low elevation and the green being high elevation. There are volcanoes or volcanic structures on Venus. They have these things called lava domes that can be seen. And Ellie, I got a term from this. I know you're trying to take notes, but check this out. These things are called lava domes. And what they suggest is that there's hot lava under Venus, under the surface of Venus. The surface is crushed like we have. There's hot lava under the surface, pushing its way up on the surface. It's kind of like the surface is being pounded from underneath. And it pushes up these little pancake lava domes. And that's what they look like, as seen with ultraviolet, with radio waves from the spacecraft that are orbiting it. And this shows one of the lava domes, but they've highly exaggerated the altitude here, so it looks like it's sticking up more than it actually does in this picture. And here's another look at it. So Venus has these lava domes, which suggests that there is a hot interior of Venus pushing up on the surface. We think that there is lava that comes out of these volcanoes at times, and we think that they may resurface Venus every 100 million years or so, so that a lot of the big craters disappear. Venus is big like our planet, so it's probably got a lot of heat still in it. Small planets lose their heat over time, but large planets keep in their heat, keep in they still have magma which comes to the surface. There's a huge volcano called Goldmans on Venus. which I have a picture of. Oh, that's this. I'm sorry. This wasn't a lava dome. This is the Goldmans Volcano. A giant volcano, not the biggest in the solar system, but pretty big. Do y'all know what a shield volcano is? It's when lava comes up from a point and then spreads out in all directions and forms what looks like a shield, like Captain America's shield sitting over kind of a big shield. And that's what that is. Again, they've exaggerated the height of it. It's not really that high.
Our flight begins at 3 impact craters. The largest crater is approximately 40...
Hold on, so they're flying over Venus here, and I think that's the big shield volcano. There's some of the lava domes right there. You see them? They don't really have a plane flying over it. What they've done is they've had a satellite going around Venus, taking pictures and measurements of the altitude, and feeds it all into a computer, and then you can kind of virtually fly around in the computer's memory here and look at different features. Let's see if that's it. I think that was the...
Regio, a highland region in the southern hemisphere that spans 800 miles. The circular feature at lower left is a corona. These features are found only on Venus and are thought to be volcanic in nature. Now we descend for a closer look at the complex terrain of Alpha Regio. Our path then zooms east over jagged ridges to a volcano with a fluted rim, unofficially called the Tip. Our journey through Alpha Regio continues over hundreds of miles of rugged territory. Turning northeast, we leave this tortured area and head to 7 pancake-shaped domes. These volcanic eruptions rise up to a half mile above the surface and average 15 miles across. They may be made of thick, sticky lava. Such domes have only been seen on Venus. Our flight then continues to the west and ends near the rim of an impact crater.
Oh, they didn't show the big volcano there. There's also these large volcanic features called corona, which it talked about in that little video. You see how this surface looks? It looks fractured. Again, it looks like something pounded it from underneath. This whole big surface feature is called a corona. It's got a lava dome inside the corona. This whole thing is a corona. And there's a lava dome, and there's a lava dome. You see all these fractures and dents? These corona and lava domes, they're where it looks like something is pushing up. And they're volcanic features. So the point here is Venus has a lot of volcanic features on it.
Wait, will you go? What was the definition of corona? Wait,
What's
go back
that?
again. Backwards. One more. Okay.
Large circular volcanic features. What was somebody else had a question?
I asked how hot it was at Plato.
Yeah, on the surface it's about 730 degrees Celsius. Which, go home, take your oven, put it on broil, get it up to as hot as it'll go, stick your head in there. It's twice that hot. It'll melt metal. And so it's really hot. It's not quite enough. It's not quite hot enough to melt the rock, though. So it's still rocky. If it got about 500 degrees hotter, the rock would melt and the whole planet would be molten again. So the Russians, the Soviets, landed on Venus in their spacecraft. It was called Venera. They had 2 Venera spacecraft, and both of them landed on Venus, took some pictures, and then melted. NASA has never gone to Venus, so that's something the Russians have one up on us. NASA's gone to the moon, we've gone to Mars many times, and even gone around Mercury, but never been to Venus. I don't know why we didn't want to go to Venus. It's expensive to take all these trips.
You can use ceramic.
Yeah, that's what we're working on, ceramic spacecraft. This is a picture that the Venera spacecraft took, the Russian spacecraft took before it melted. That little thing right there is part of the spacecraft's legs that landed. And so is this. This is part of the spacecraft. It landed, it kind of rolled this thing out, took a couple pictures, and then melted.
Did they expect it to melt?
The first time they didn't know. The second time they knew it was going to melt, and so they had it set to do things as fast as it could. And it still melted. They tried to protect it with certain types of insulation, but it didn't help. Venus does have impact craters, but the craters erode due to the atmosphere and the volcanism. So there's not nearly as many craters on Venus. Venus is more like the Earth in this respect. There are craters on the Earth, but just not that many. Sam, you getting all this? It's good stuff, isn't it? Maybe one day you'll go to Venus, Sam. Who knows? That one looks like a face. Okay, and so tomorrow we spend 2 days talking about Mars. So I'm going to start a little video that talks a little bit about the atmospheres of these planets. And there are questions on the test about this video. So pay attention.
A billion kilometers from the Earth, a small probe uncoupled from an interplanetary spacecraft and headed for its target. It had a date with Jupiter. In an encounter that would break all records for speed and violence, the probe accelerated towards the largest planet in the solar system, plunged into its fearsome clouds, and was swallowed by its atmosphere.